right, fifth graders, we have been working on division for this entire week and a little bit of last week too. And today we're gonna kind of put it all together in the three types of problems that we've seen and see that kind of the same thing is going on every single time. So you're gonna need a pencil, and I need you to grab that math unit 3 packet number 3. Yes, sorry about all the packets. I just can only make so many notes at a time, creating all this as we go. So thank you for your patience. So again, the title on the front would say Math Unit 3, Packet Number 3. These are our notes. So you're gonna flip that page to Lesson 9. And it looks like this. Practice division, putting it all together. And remember, whatever I write, you should write. Okay? All right? Right. So we are going to look at 3 different situations, and they're the situations we've been kind of looking at this week and a little bit of last week. And our first step is going to be to draw a diagram for that situation, and then we're going to put an equation and solution along with it. And we'll find that you'll end up having 2 equations. You'll have probably a division equation, right? Because this is practice division. And then we'll see what we do with those division equations in order to solve them. So here is our first situation. You have 2 cookies to share between 5 people. How much does each person get? So for our diagram of this, what do we start with? We don't start with 5 people. We have 2 cookies that we start with, right? So that's what we're sharing. So I'm going to draw 2 cookies. You should too. Okay. So now we have to share these 2 cookies between 5 people, all right? So that means we're going to take each cookie and cut it up into 5 pieces. All right, so let's see here. I want 5 pieces, so this is going to be a little bit tricky. 1, 2, 3, 4. 1, 2, 3, 4, 5. That one's a little bit bigger. Just pretend it's not. Okay? Do your best. 1, 2, 3, 4, 5. Okay. So each of these cookies is cut up into 5 pieces because we're sharing it with 5 people, right? How much does each person get? Well, if there's 5 people, each person would get 1/5 of each cookie, right? That's how much they would get. So the answer here would be 1, 2, 2/5. So in terms of what did we just do, equation-wise, didn't we start with the 2 cookies, right? And then we divided those cookies up between 5 people. So our equation would be 2 divided by 5, right? And we said that our answer was 2/5. So when we try to figure out, okay, like, how did we get that answer? I know with the diagram, this really helps, right? We just counted 1/5 plus 1/5. So didn't we have 1/5 twice? So 2 divided by 5 is the same thing as 2 times 1/5. Because if you have 1/5 plus 1/5, you're going to get 2/5. So these equations right here will give me the same result. So instead of doing 2 divided by 5, you can do 2 times 1/5 because it means the exact same thing. So that was the examples that we saw like last Friday. Okay, so now I have another example here. It says you have a 4-pound bag of dog food. Each day you feed your dog 1/3 of a pound of food. How many days will the bag of dog food last? Okay, so you start off and you have this 4-pound bag of dog food, right? So I'm just gonna draw a 4-pound bag of dog food, why not? And let's see here. Well, we can do that. Here's our 4-pound bag of dog food. And we feed the dog 1/3 of a pound of food every single day. So that means that every day we're taking out 1/3. So on day 1, we take out 1/3. And then on day 2, we take out another 1/3. And on day 3, we take out another 1/3. So we keep taking away 1/3. That's repeated subtraction, isn't it? So you know how repeated addition is multiplication? Repeated subtraction is division. And what are we dividing up here? We're taking this 4-pound bag of dog food. That's what we're starting with, isn't it? And when you divide, you can't change the order of what you start, like you can't change what you start with. So if we start with this 4-pound bag of dog food, And every single day we're taking out 1/3. That means we're taking 4 and we're seeing how many 1/3 are in this bag. Okay, so if you want to do 4 divided by 1/3, that's the same thing as asking you how many 1/3 are in 4 pounds. Well, if we have 4 pounds right here, how many 1/3 are in one of those pounds? 3, right? So if there's 3 in 1 pound, then there'd be 3 in another, and 3 in another, and 3 in another. 3, 6, 9, 12. So that means this is going to last for 12 days. Didn't we just do 3, 6, 9, 12? Didn't we just do 3 4 times? So 4 divided by 1/3 is the same as 4 times 3, which is 12. So in this equation here, when we were supposed to divide by 5, we saw that we could also multiply by 1/5 and get the same thing. And here, when we were supposed to divide by 1/3, we saw we could multiply by 3 and get the same thing. Hopefully you're going to see some patterns start to emerge here. All right, the last kind of problem that we've seen over the last 3 lessons is you have 1/4 of a birthday cake left over to share between 2 people. How much cake does each person get? So you have 1/4 of a birthday cake left. So here's your birthday cake, and you had the party, okay? And then there's 1/4 of it left in the fridge. So this all got eaten up, and this is how much is left over. So now you and someone else want a midnight snack, okay? So this is how much is left, and we're gonna share it between 2 people, right? So I'm gonna go ahead and cut that into the 2 pieces of people I'm sharing it with. I'm asking how much each person gets. Well, if I'm sharing these pieces, each person would get 1 of those pieces, right? But 1 what? Isn't your denominator supposed to be how many pieces the whole is cut up into? And right now, this piece and this piece are not the same size. So in order to figure out how many pieces the whole is cut up into, I need all the pieces to be the same size. So if I cut this 1/4 into 2 pieces, I need to cut this 1/4 into 2, this into 2, this into 2. So each person gets 1 out of 2, 4, 6, 8 pieces. So 1/8. So what we just did here, equation-wise. And pictures are powerful. So if you can draw this picture and get the 1/8, I'm totally good with that. But I do want you to try to connect it to an equation as well. So we started off with 1/4 of the cake left, right? So what we started with was 1/4, and you can't change what you start with. And then we took that 1/4 and we divided it between 2 people. And we ended up getting 1/8, right? Now, we saw in class that dividing by 1/4 was the same as multiplying by 1/2. And didn't we just change that 1/4 into 1/2? We cut that into the 2 pieces. So 4 times 1/2 gives me 1/8. So that means that dividing by 2 is the same as multiplying by 1/2. So I want you to kind of take a look at all 3 of these. Dividing by 5 is the same as multiplying by 1/5. Dividing by 1/3 is the same as multiplying by 3. Dividing by 2 is the same thing as multiplying by 1/2. What are we seeing happening here? Like, what's the relationship between 5 and 1/5, between 1/3 and 3, and between 2 and 1/2? Maybe you're noticing, okay, well, this is a whole number 5, and then here I see the 5, but it has a 1 over the top of it. And here I start with the 1 over the top of the whole number of the number 3, and then end up with a whole number 3 here. And here I start with a 2, and now 2 is in the denominator. So each time we're putting that 1 there. If I start with the whole number, I'm taking 1/5 when I multiply. These right here are called reciprocals of one another. And that's basically just switching the numerator and the denominator. So for example, and I do want you to write this, if I had 2/3, the reciprocal of 2/3 would be 3/2. So all I did was I switched the numerator to the denominator and the denominator to the numerator. So these are reciprocals. I'm not going to make you memorize that just yet, but I do want you to have heard that word and put it in your memory bank a little bit. So when I say that I am multiplying by the reciprocal, you might say, well, this one doesn't have a denominator. Like, what are you talking about, Mrs. Tremblay? Well, if I have a 5, can't I write that as 5 over 1? Yes, I can. So the reciprocal of 5 over 1 means I would take that 1 and put it in the numerator spot, and that 5 and put it in the denominator spot. So the reciprocal of 5 is 1/5, because 5 can be written as 5 over 1. So really what we did here was we multiplied by the reciprocal. And for this one, we did the same thing, because if you have 1/3, if I write the reciprocal of 1/3, that means as a fraction, my 3 would go into the numerator and my 1 would go into the denominator. And what's the value of 3 over 1? It's 3. Same thing here, 2 and 1/2. If I have this number 2 and I want to know, okay, how do I write that, the reciprocal of it? I'm going to write my 2 as a fraction and then take my denominator, make it my numerator, my denominator. So for every single one of these, what you actually did was you multiplied by the reciprocal. And that gets you your answer, because multiplying by the reciprocal is the same thing as dividing by that original. It actually works for regular old numbers as well. So I'm going to show you, and again, like, I do want you to write this. It's kind of a big deal, so you should write it. So we know that 12 divided by 4 is 3, right? That's just one that we've known for a while, I'm sure. Now I'm telling you that multiplying by the reciprocal is going to give you the same answer. So whenever you divide, if you use your opposite operation of multiplication and you multiply by the reciprocal, by kind of the opposite, you get the same result. And I'll prove it to you right now. 12 divided by, what would the reciprocal of 4 be? Well, I could write 4 as 4 over 1, right? So the reciprocal, oh, I went to say multiplication there. That defeats the whole purpose. Make a big fat multiplication sign there. All right, so if 4 can be written as 4 over 1, the reciprocal of 4 over 1 would be 1 over 4, right? So I'm trying to tell you that 12 divided by 4 is the same thing as 12 times 1/4. And to prove it, let's solve it. I will put this 12 over a 1, right? And some of you might cross out the 4 and put a 1 and cross out the 12 and put a 3, right? We know that 4 goes into both of those. And some of you might just say, well, 12 times 1 is 12, and 1 times 4 is 4, and 12/4 is 3. Isn't that what we just got there? Yes, so this is proof that whenever you are dividing, you would get the same result using the opposite operation if you multiply by the reciprocal. It works every single time. Okay, so come down here to these generalizations. And I know it gets kind of tricky when you see all these letters, okay? Don't let them throw you off. This just means that any numbers that you're working with, okay? So n divided by d is the same thing as n times 1 over d. And what this means is that I can't change what I start with, so we leave the n alone in both, whatever number we start with. And dividing by d is the same thing as multiplying by 1 over d. It's the same thing as multiplying by the reciprocal, because I could write this as d over 1. So if you have n divided by d, if you have a number divided by another number, you can simply write that as a little division problem like this, as a fraction, because fractions are division problems. And here, if you see, okay, I have a whole number and it's divided by a unit fraction here. So I have divided by 1 over d. I get the same result if I just left what I started with alone and multiply by the reciprocal of 1 over d, which would be d over 1. And any number divided by 1 is itself, even if it's a letter. And the last pattern that we saw was if I have a unit fraction and I'm dividing it by a whole number, I'm going to keep what I start with, and I can multiply by the reciprocal of that other number, which would be 1 over w, because this is the same thing as w over 1. I know when you look at the letters, it's like, oh, this just isn't making any sense. So let's do it with numbers, okay? We're going to do a couple practice problems right here. The first one, I have 3 divided by 10. So what I would like for you to do is write this as a multiplication equation. Regular old division problems like 12 divided by 4, we don't have to rewrite that as multiplication because you can divide those evenly, right? But when you're dealing with fractions or you're dealing with wait a minute here. 3 divided by 10, how am I supposed to take 3 and divide it by 10? These are the kinds of problems where it's like, oh, okay, these are fractional amounts. So I'm going to use the strategy of multiplying by the reciprocal to help. So 3 divided by 10 is the same thing as 3 times. And remember, you can look at this as 10 over 1, 1/10. So 3 times 1/10 will give me the same thing as 3 divided by 10. And if you have 1/10 3 times, or maybe you want to put the 1 underneath there, you're more than welcome to. But you would get 3 times 1 is 3, and 1 times 10 is 10. 3/10. Okay, for letter B, 4 divided by 1/3. Remember, when you're dividing, you can't change what you're dividing up, and we're starting with 4. So I want to know how many 1/3 there are in 4. I can get the same result by saying 4 times the reciprocal of 1/3, which is 3 over 1, which is 3. So 4 times 3, that would be 12. All right, so that one's going to fit into this pattern right here. For letter C, I have 1/2 divided by 5. So this is where you have like half of a pizza or half of a cake or half of a cookie, half of whatever, and you're sharing it between 5 people. I want to know how many each person gets. Well, I can't change the half of the whatever I start with, but I can, instead of dividing by 5, multiply by the reciprocal of 5. And this 5 I could write as 5 over 1, so the reciprocal of that would be 1/5. So 1 times 1 is 1, and 2 times 5 is 10. So 1/2 divided by 5 would give me 1/10. That means if you have half and you're sharing that half between 5 people, each person gets 1 piece, but it would be broken up into tenths so that you have the same size pieces. All right, maybe try D, E, and F and then press play to see if you are correct. That would be a good idea. And if you're not feeling comfortable with it yet, then just do them with me. It's okay. Okay, I have 1/3 divided by 4. And I see, okay, I'm dealing with fractional amounts here, so I'm going to use my strategy of multiplying by the reciprocal. So instead of doing 1/3 divided by 4, I can do 1/3 times 1/4. And that would give me 1/12. For letter E, 5 divided by 8, that's not going to come out to a nice whole number, is it? So let's use the strategy of multiplying by the reciprocal, or reverse, whatever you want to say. So this would be the same as 5 times this 8. I'm going to rewrite it as 1/8, because technically this 8 is in the numerator spot. I want to put it at the bottom so I can take the reciprocal. So if you have 1/8 5 times, that means you have 5/8. And if you wanted to put the 1 underneath that and do 5 times 1 is 5 and 1 times 8 is 8, you go for it. All right, letter F, I have 7 divided by 1/2. So I'm going to go ahead and, because I see I'm dealing with fractional amounts and this isn't going to come out to something nice and pretty, I'm going to multiply by the reciprocal of 1/2. And the reciprocal of 1/2 would be 2 over 1. And 2 over 1 is actually 2, right? So 7 times 2 is 14. So this is just saying that there are 14 halves in 7, which makes sense because aren't there 2 halves in every whole? So that would mean for every one, you'd have two pieces. So 7 times the 2 gives us 14. All right, we're going to do the other examples that go along with this tomorrow. This was definitely enough for today. I'm hoping that you're making some connections and seeing, okay, when you divide, we can use inverse operations. Inverse means opposite. You can use multiplication, and if you multiply by the reciprocal of whatever you were dividing by, you will get the same answer you would have if you drew one of our lovely diagrams. And please keep in mind that I am good with you drawing the lovely diagrams. All right, that's being a good problem solver. All right, you're all set with your notes. Thanks for watching.